What is going on, everybody? What's going on? My name is Ian Robinson. I'm the lead ZBrush trainer and training manager here at Maxon, and we're going to be making a lot of fun videos today, going with 3D printing and a bunch of stuff. So fun stuff and things. Yeah, it's going to be great. So welcome in, and of course, everybody is super excited for it. So awesome. Bruno, thank you so much. Melon, it's always good to see you. Travis, hello. Rodolfo Silva, what's going on, dude? Glad you can make it. Leonard, hello. All right, so today's going to be a good one because we're going to be getting into prepping for 3D printing. But before we do that, oh, hey, what's going on? Zoe Arts, how you doing? Yay, glad you made it. So we're going to be doing a lot of 3D print prep. But before we do any of that stuff, let's go ahead and let's go through a couple of the fun stuff and things to do. Number one thing, of course, is that we are Maxon One, so we have basically all the 3D needs for you in one suite. And we also have a plethora of events that are coming through time and time again, like today's 3D printing. And then also, too, we got one going on next week. We also have VFX and Chill. They're doing something later this week as well. And of course, this Raptor. This is a fun one for me. And then lots of events, lots of stuff and things. So if you want to get caught up on what we do and how we use these tools, this event page is perfect for you. And then, of course, if you miss any of these streams on the Maxon Training YouTube channel, we have everything that you might have missed. So if you're curious about Redshift, ZBrush, Cinema 4D, Universe, etc. If you're curious about any of this stuff, or you happen to know that I was streaming today and you're just at work and you're doing something else, and I totally understand that that's what's happening, it's okay. We all have we have stuff to do. You won't be able to miss it forever because you'll be able to catch it back here. So VODs are always over here. And then we also have Maxon's University. So this is where you get to learn the stuff and things. This is where it's like, how do I get started in ZBrush, for example? You know, you come over here to University and just click this link, and you'll be greeted with the lovely Anna Carolina, who will come in here and talk about all of the stuff ZBrush related. It was so awesome of her to actually put this tutorial together. Her and I came through, and we just kind of thought what is the most important ways for you to get started. And it was really a lot of fun collaborating this project with her. So definitely check that out, especially if you're lost with any of the tools or the stuff today that we're talking about, because there are some names that might be a little bit different, you know, like subtool instead of object, etc. So if you're unfamiliar, then this will be a great series for you. And then, of course, once you get really comfortable in our tools, we have our certification process. And this is to test your ability on if you know the software and you'd like to become certified in that. And then not last but not least, but also too, if you're a student or a teacher and you're wanting to go through and actually get our tools, then check this out. Come follow the links below, because the price is per region. So in the US, it's $20 per year, and you just get, you know, you have your valid EDU license. And for there, you can use all the tools, and it's absolutely there for you to learn that process. So this is a really good spot, especially if you're going to schools like Noman, if you're at a university and you're going through and wanting to check out our tools. This is a great price for the year, which is awesome. And then you just validate it once a year. And then if you're hanging out with me, and that's awesome that you are, then you get a free t-shirt. Yay, free t-shirt. So there's going to be a code down at the bottom for you to go through. And if I remember right what the code was, you'll be able to type that in. Kyle will be posting it. Thank you, Kyle, in the chat. So grab that code. I think it's ZBrush prep or something like that. So awesome. So that is what we're going through. So let's pop into ZBrush. Also, I see some questions coming through, and questions like this: is there a series for FDM 3D printing? So check this out. Most of the information that I'm going to be sharing with you today is going to be for both Resin and FDM. The only real difference when you're prepping for one or the other is just keeping in mind that with FDM, a lot of users want to try to keep it as minimal supports as possible. However, in today's FDM world, with tree supports, which is a really big favorite amongst most, it's actually becoming quite the same. The only real difference is how much time you're going to be spending printing, and of course, cost on materials and stuff like that. So Resin and FDM, while they are very different machines and still require some different types of approach in your thought process, everything I'm going to show you today can be applied to both, and that's super important for you. So awesome. So let's go ahead and let's first talk about what it is we're going to get into today. This first week, let me just tell you, it's going to be the most jam-packed with like math information and scaling and checking all of this stuff up. So feel free to, like, if you're already at this point in time and you're rewatching this video, feel free to like slow down, check out everything I do, because we're going to cover all of those good points, and we're going to be doing this over the next 2 weeks. Then we're going to have a special guest come in, and then after that we'll do a wrap-up series and showcase even Lychee Slicer as the slicer of choice for me. So first off, 3D printing. What are we doing here? Well, this is my Leonardo. A little fan art for Teenage Mutant Ninja Turtles. Love this guy. One of my favorites, of course. I think he's a lot of people's favorites. Just going to say. But we're going to go ahead and explode him by hitting Shift X. And you can see here that I have all of these different pieces. And the thing that we're really going to be focusing on, of course, is that we have key cuts. So we have cuts here, and we have a key insert. So, and you'll see that all of my parts have this structure on it. If we go ahead and actually just zoom in on a piece, you can see again that I have a tapered key here, and then I have a cut. Now, when you're prepping for 3D printing, it's important to remember that you get to decide what gets cut and what doesn't get cut. And one of the things you'll notice is that I try my best to hide my cuts because I want to honor the model as much as possible. I want to be able to showcase the model without too many disruptions. Sometimes, however, you can't avoid that. Like, let's zoom in on the back of his neck right here, and you'll see that there is a little bit of a cut here. This is normally okay once in a while. You know, again, depends on the model and what you're trying to go for. But a lot of times it's easier to work with multiple pieces than try to get everything in as one big piece. And of course, this is mainly for 3D printing. Just think about like if you move into the toy world when you're working with machinists and manufacturing process, especially with stuff like, you know, injection mold, all of that, there's always an approach for that. But today we're going to keep it very simple and very easy to get into it. So how do we make these keys? This is the most important thing. What's up, 3D Mac? How you doing? Kenneth, hello, hello. Cool, checking the chat. As you can see, I can see the chat. So hello. So how do you make these keys? What should I even do to start learning this? Well, the thing is that I actually recommend learning on a cube. And that's because when you get a brand new 3D printer, it's actually good to create a test cut and try it out so you don't waste a lot of resin, and you actually get an idea of how your machine, what your machine's print tolerance is. Because one of the things you'll notice is when you start 3D printing, the whole process, whether it be with filament, which is plastic that gets melted down and then gets, you know, hardened and cooled over time, and then, or is it resin that's a liquid that's turning into a solid? At the end of the day, just with those two pretty popular options, you have a shrink tolerance, and that is when something actually, you know, when it gets heat, it grows. When it gets cold, it shrinks, right? So it's that mentality. So every printer has a shrink tolerance, and you can buy two of the exact same printers, and those printers might have different tolerances. Even though they might be close to each other, it just varies. So every machine is very different. So how do I start with this? Well, that's a great question. So I'm going to go ahead and stamp this Leo on the side, and let's actually grab a cylinder here. And I'm going to be working with perspective turned off. If you work with perspective turned on, I recommend for the cutting process, you turn it off. And that is because you actually, like, see here, at the very top, I have a nice straight line. I can make a solid straight cut across. But if I have perspective turned on, now everything looks a lot warped. And what you might think is a straight cut actually could be off tapered or even bowed a little bit. So you want to work, in my opinion, with perspective turned off. It just makes the process a lot easier. So now with this, what we're going to do is let's get a cube in here. So I actually like to just come on down to initialize. I'm sorry, not initial. Yep. Boop. I have to make it Polymesh 3D. Let's do that. So make your cylinder Polymesh 3D. Go to initialize and let's hit a QCube here. And that way we have just this guy. All right, perfect. Now there are many ways to make keys, and let's go over a couple of them throughout this process. But the first thing is scale or size. So that's what you really want to associate. When you're 3D printing, you want to know that you're working in scale. So how do we do that? So let's go up to the Z plugin, and we're going to dock that over here on the left-hand side. And to do docking on any palette on the left or right side of ZBrush, you just open up the Z plugin and you hover over this nice little clock thing, and you can literally drag it on over to the left or to the right, and then that will dock it on that side. And if you want to get rid of one, you just hover over that spot, like let's say render, and you tap it, brush, I don't need that. and you just tap those and that gets rid of it. ZBrush's UI is completely customizable, so you can actually set this up exactly how you want and save that for later. And of course, we have videos on that as well. So looking through real quick, what glove is that they use? So the glove is actually the Maxon ZBrush glove. And I believe, Kyle, correct me if I'm wrong, but I believe we have those. Do we have those in the shop? I know we get them at events. I'll let Kyle answer that. I don't want to misquote. Student, real quick before I go on, the student license, real quick that popped up. Do only the physical schools get the students, or is there different online or websites licensing? Well, great question, 3D Mac. As I understand it, basically the school has to have an EDU licensing, like a certification, to be granted as a proper university. You should be able to talk to the school and ask. But if I remember right, most of the time they're going to be the physical ones, and they can still offer an online course, but it depends on the school. They have to be recognized as a proper EDU. So like Nomen, as an example, is a proper EDU school, so they would be able to grant that for you. But you just check with their school; they should know that information. Great question, by the way. Okay, so hey, that one, 3D artist, how you doing? Okay, so we want to start with scale, and of course, we want to be able to be like, what's the size we're working at? We can't make any determination on how big or small something is without that scale. Now, the scale I like to work in, and most of the time, if you're new to 3D printing, you're going to find out that the metric system is the #1 go-to system. So I'm going to give you the cheat right now. I'm going to name our subtool. So we're going to do this together if you're following along. We're going to name our subtool 25.4 millimeter. Okay, it might round up to 25, but it's 25.4, or sorry, round down rather, 25.4 millimeter. What you could do, because it doesn't take decimals, you can do 25_4 millimeter. So then you know it's 25.4 millimeter, and then you could type in scale. And what this number associates in inches is 1. So 1 inch is 25.4 millimeters. And this is really important for you to understand that, because again, when we're starting to deal with tolerances and how big or small something should be, then it's really going to be helpful to you to understand it, especially with like FDM. The typical layer height is 0.2 millimeters. That's your typical layer height. So if you want to be able to apply glue or get magnets in there, then you want to make sure there's enough space for that to be. And so we got to set that scale at the gate. So I'm going to name this cube 25.4 millimeter. And under Z plugin, we're going to go to Scale Master. I'm just going to move this tablet so it's more comfortable. And then we're going to hit Set Scene Scale first. We don't want to touch anything down here at the bottom, because over here, like right now, everything is set to the unit size. And this is something to kind of call out too before we get into it. Every single project you're working on in ZBrush, if you go over to the Geometry tab under Tool and go down to Size, what you'll notice is every project has an associated size. And a lot of times you'll see that the size can vary. Like this is 0.4, this is quite small, but I've had projects as big as 16, 17, scale size. So this sizing right here ultimately is going to tell you how big or small your model is. And the sizing also directly correlates to DynaMesh as well. If you're unfamiliar, that DynaMesh is using your resolution of your viewport. It's through the sizing. So when you increase or decrease something, every time you come through and look at this right here, every time I scale this up or down on my gizmo, every time I go like this, boop, boop, my size will change. So I can go 0.2, I scale this up, and now it's at 1.5. So anytime you come through and you would scale something up with a gizmo, you're actually affecting the overall scale or the size of that object in your scene. And so that's just something to kind of know. So that's why we come over here and we say Set Scene Scale. And when we do that, we're telling ZBrush, please default to a unit measurement. It already defaults to millimeter, just fun fact, even if it just says 1.2 units. It's technically millimeters, but we want to see that it's millimeters so then we can get all the right math stuff. So I'm going to say millimeter. So it's saying that it's 0.88 by 0.88 by 0.88 millimeters. That's okay. We're just going to pick that one. And of course, too, we also deal with centimeters, inches, and feet. While you can work in those, I find that millimeters is just the best option when working between multiple different types of printers. So now that we have that, what we can do is we can resize this to a size that we actually want it. So I'm going to just click anywhere in this number system, and I'm going to type 25.4 millimeters. And now you'll see something like this. And now we're going to come on down, and there's a button called Resize Subtool. And we have the all that's defaulted as turned on. That means all axes, X, Y, and Z. So from here, we're just going to go Resize. And now it should resize that same. So I'm going to go ahead and zoom out a little bit so we don't cover up Leo here. Use our prime example. And now we want to verify that this is actually 25.4. So if we just hit set scene scale one more time, you'll now notice at the very top here, it says 25.4 by 25.4 by 25.4. So now we know that our scene is set, or this cube is set to 25.4. So now anything that we do to our model here as we prep our key cut, we'll actually be able to kind of figure out how big or small something like that will be by measuring. Fostacker says, I always keep a millimeter conversion chart. Absolutely. I also will sometimes just type into the Google at the top. I'll just be like millimeters to centimeters, or millimeters to inches, or inches to millimeters. It's a great resource. Absolutely good to have. Let's see here. A real quick question. I have a question. If you are printing and trying a small pendant in Cura, what do you think would be a normal measurement? So that's a great question. You know, what I would do actually to find that answer is if you have a similar pendant that, you know, is about what the size you're going for, just measure that. Get a ruler or a pair of calipers and measure that for you. That way you know what the size is. Typically pendants are quite small. You know, I don't, you know, it just depends. So you can kind of use your best judgment. Every pendant is different. There's no, as far as I'm aware of, there's no like set in stone standard for like a hanging pendant. It's just, you know, what would be comfortable. Obviously, you know, we don't want a giant clock. If you remember what I'm talking about, maybe you do want a giant clock on your chest. That's possible. So it depends on how big it is. Honestly, you don't want it super, super small where nobody can see it. So a decent size would be pretty good. But honestly, the best part about this process is that when you're making stuff like jewelry, that's really like you kind of just find something that's around normal, what you would see, stuff you own or stuff you see in your friend zone. Just get a sense of it and then just make it so that it looks kind of nice. So it just depends. There's also like jewelry courses, and maybe we can get a DPP going where we bring on a jewelry expert to help answer more of those questions, because I too want to get a little bit more into jewelry. I think that's fun. And you know, then you guys can sing that he's making jewelry now. So now we have our scaling, and great questions, by the way. Please keep them coming. It's amazing. So now that we have our scaling, one of the things that, so we got an answer. Sorry, I cut myself off. The ZBrush gloves are not at the store. We have them at physical events, but we're looking to get them into the store. So for the ZBrush gloves, if you come to the events, come see me, come see Paul, come see the Maxon team, and we'll get you a glove if you're there. Awesome. And Rodolfo Silva coming in clutch with the millimeters, the centimeters, and all the way through. So awesome. Thank you, man. Okay. So now that we have our scale, let's go over the different ways we can actually do some cutting. Now this is quite low resolution to do a test cut, right? So let's just go ahead and hide this. So what we want to do is now let's explore the ways we can make articulation, because this is going to be something that's really going to, like, that's what you're here for, right? How do I make an articulated thing, i.e. like a key cut? We're not going to deal with motion articulation. We're not going to be dealing with like movement joints, maybe further down the line. But for today, we're just going to do our simple plug-in keys. So just simple tapered cut keys. We'll get into more of that other stuff. So how do I cut this? Well, first we need some resolution, because this is quite low. Like, this won't cut as well as I want. It's literally only 26 vertices. It's not a whole lot. So let's get some resolution here. So I'm going to go into geometry, and I'm going to turn off the subdivide smooth modifier. I'm going to turn that off, and I'm just going to divide a few times and then delete. So I divided up to subdivision level 4, then I delete lower. This gives me a little bit more resolution. Now, sidebar, you could get very clever with this really quickly. You literally can come through here, and let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? So literally, you could do something like this. You can count that this is 16 by 16. So you can come here, and if a piece of your tool fit right here within one square perfectly, that's 1/16 of an inch because we have 16 squares. Because we sized this to be 1 inch cubed, we know that what we're looking at is 1 inch. So in the US here, or just, thinking in the imperial system for a second, these are 16, so each one is 1/16 of an inch, which is good. So you could actually end up using this to measure. So how do we measure? So if I turn on my gizmo by hitting W, and then I hit Y to bring up the fancy transpose line, I could literally start to click, hold shift, and go vertice to vertice. And that 1/16 of an inch is 1.5874 millimeters. Now, and I know that because it's at the very top. Now, it might be, hopefully it's not covering, but at the very left-hand side top, it tells you that number. And that will signify the size of that. So 1.5874. So that's 4 decimal spots. To give perspective, the human hair is, I believe, is like the 3rd decimal spot, just to give you an idea of how thick something might be. So 4 decimals is actually that's quite small. So you're going to be able to get a fairly accurate measurement really quickly within ZBrush. And so again, with that transpose line, you just click anywhere, press and hold shift, drag it down. And what is this now? So this is now 7.9372 millimeters. So you're able to really measure from point to point. And because ZBrush is vertice based, that means that we're measuring from one point to another, and it snaps. And if for the reason why I'm holding shift is that I want to ensure that it is a straight line, but you don't have to. If I know I'm working on a flat plane like this, and I just go from one to another, it's going to measure that straight. It's just really when we start getting to rounded objects, are we going to notice that we want to have a straight measurement from point to point. So, but as you can see right now, this is 12.6996 millimeter. So this is how we would be measuring inside a ZBrush. The hair is between 50 to 110 micron. Yep, absolutely. Hey, what's up, Jamie? Hey, thank you, man. Thank you. Absolutely. Oh, perfect hair. Poly Workshop, glad to see you here. We're going to go ahead and just spotlight this real quick. Oh, boop, right there. For a model that is 250 millimeter tall, I would work at scale, which is 2.5 in ZBrush, and export by multiplying 100 in 3D Print Hub. Works pretty well. Absolutely, that works pretty well. The approach that we're showcasing today hopefully will be a little bit simpler, but yes, that is absolutely correct. Yep. Absolutely. Yeah, this is the fun part, is that you actually, with scale, this is the most complicated part about this conversation, in my opinion, is the scale function of it. Because, again, we have to understand the complexity in which these machines operate, and there's that tolerance that's built into it. So we want to be as accurate as possible. So, but great information, Poly Workshop. Awesome. Thank you for sharing all that. Okay, great. So now we have the subdivide. So now, again, like I said, you can get really clever with this. You can literally use these notches as like 1/16 of an inch, which is fantastic. If you wanted to get that complex, you absolutely can. But for today, just note that we really just wanted some resolution to make our cuts. Now, there are a couple ways to go about making a key cut inside of ZBrush. First way I want to showcase is actually a new way that I started utilizing it in 2024, and that is actually utilizing the knife brush. So for example, right, beforehand, if we had the knife curve brush, and let's go ahead and save this. I'm going to go ahead and hit save as real fast. I'm going to come up here to my document. We're going to type in DPP episode 1, printing tips, scale. Boom. Now we have it. Oh, it's Tama from Lychee. Oh, perfect. Oh, Tama, dude, I've been meaning to talk to you too, by the way. Everybody go follow Poly Workshop. Tama from Lychee Slicers, perfect. And again, I mentioned earlier in the stream, I do want to be showcasing my print workflows and stuff like that, utilizing Lychee, but I definitely, Tama, we got to talk, buddy. Okay, so coming through here right now, again, what we want to do is, so the new way to cut it is actually using the knife curve. So before, if you've used the knife curve before, you know, you cut here and it cuts a chunk of that, and now boom, you have a piece that's taken away. Well, now the new feature is that if I press and hold the shift and control key and I press the space bar, I now get the ability to split into parts. So now this gives me, if I cut like this, and now masked off a section, and now I just cut a piece right here. And then of course too, if I cut again, then I just cut another section, right? So I can have this section here, this section here. This is new inside of 2024. And again, this is just a way to kind of split things off. And as you notice, not only is it's splitting, but it's also closing it because that's what the knife curve does. But now it's keeping that piece. So a way I've been playing with this is I've been coming through and actually turning on the splits to parts, which again is pressing Shift and Control, pressing the space bar. But I also can change its polygroup. So now I can come through, cut this, and now it gives me a different polygroup. So now when I separate this, you can see here that I have different polygroups so I can make different selection sets. So, and I can even use that mask to Control W to then get a single polygroup across everything. Control Shift drag to switch, and then Control W again. So now I have these different polygroups. And with this way, what's fun is now I can literally come through here and I can do a split hidden. And I have both pieces already good to go. And I can use this to put a key in there. So making the key is the next spot. Like we don't have the key right now. We just had two different pieces. So we're going to come through and I'm going to insert another 3D cube. There it is right there. And something I like to do with this, again, let's just hit F on the keyboard to make this nice and big, is I like to come on down here to initialize and QCube, and I can do this. If you don't want to do that method, there is actually another method that I don't think it's enough love. If I hit W on the gizmo, then I open up B for brush, I for IMM, and then T for my insert. You can see here with the gizmo open, and I can scrub through, and I can actually pick all these different QCubes. So I can come in and say, yeah, here's my QCube, and there you go. So with the gizmo and then IMM brush, I can actually come in here and pick the different ones that I want. So I would say I could do QCube as well. So if you don't always want to go down to initialize, just pick an IMM brush, and boom, you are good to go. Hey, Matthew. Yep, I'm definitely going to be at NAB. Absolutely. I'm also going to be at GDC in a couple of weeks. So if you guys are there, please stop by. I'll be hanging out with Sense Labs and I'll be hanging out with Dell. Okay, great. So now let's go ahead and I'm going to do the ZModeler brush real quick and just get rid of these edge loops here for a second. The reason why I wanted to do that is I actually want the easiest way to create my key, which is literally just masking down the bottom. And I invert that by control tapping. And then I'm going to go ahead and take my gizmo and just hold Alt, which unlocks the gizmo's position, allows me to move my gizmo around. And I'll hit that location. And now I will just scale this down just a little bit. And there I have I essentially just made my taper key. Now this is super low resolution. In fact, it's lower than the QCube. We started at 8 vertices, right? So here, what we want to do is I like to subdivide this again. So I'm going to turn off the smooth modifier for subdivision and divide a few times, and then just delete lower, and maybe a couple more times, just to give me a little bit of tolerance, because the trick I like to use, that's a little too much. Trick I like to use is I don't like to have my keys super sharp. One thing you'll learn in the manufacturing world is a sharp edge is a bad edge, because that sharp edge not only could, of course, cut you and stuff, but also too, when a sharp edge is super, super sharp, the smallest grain of sand can literally stop it from inserting into your mesh. So anytime I see a model with like a squared key that's literally just a square, those always seem to be the most difficult ones to insert, so that's why we end up tapering them. If it's completely squared off and it's super sharp, then the tiniest little imperfection in that sharp edge can cause it not to actually sit there and insert into the proper key. So then you end up sanding and spending time. So here what I like to do is I like to subdivide a little bit with the smooth modifier turned off. Then I'll turn it on and I'll do it again a few more times. And you can see here, this now gives me a nice, like soft fall off to that edge. And this has never failed me. This has always been a key that's like, boop, just inserted correctly. So it has nice softness to it, and it's perfect. And it's not super dense. We're going to be decimating our models at the end anyway before we export out for 3D printing. So it doesn't really matter the density of it now. It's only just about 100,000 active points. So it's really not a big deal, but this will just give me a nice profile. and then I'll delete lower, and then I have this. So now let's go ahead and turn back on the main model real quick. And I'm just going to, of course, turn off the lower one, and I'm going to move the key just in between the two pieces, and then we're just going to scale this up. And now the fun part is we get to decide how big or small we actually want this key to be. For me personally, I try not to make them too big, and I also try not to make them teeny tiny. I like to just kind of find a good happy medium spot. And again, if you want to know how deep something is going to be, then I can literally come over here to this piece, and I can turn on my gizmo, get the transpose, and I can pick a point, and I can hold shift and get right about there. And I know that this key is now pointing out about 4.433 millimeter. So that's actually not too bad. Visually, this will be fine. But, you know, at the end of the day, it's like, yes, this is actually, that's 4. So we can then determine, do we want this to be sticking out a little bit more, a little bit less? It's up to you on that one, as long as the key itself is not going to penetrate out the side of something. So for example, you don't want this. You don't want the key to be so big that it starts sticking out, or you don't want it to be so big that if we hit the transpose here, we don't want this to be so big that it's like giving us tiny wall tolerances. Like, look how small that would be. That would be detrimental in the actual print. Like, this could cause a hole because that's only like 0.1343 or 73 millimeters. So you want to make sure that your key has enough room, that there's enough wall thickness, and you'll hear that term a lot. There's enough wall thickness or spacing between the key itself and the actual model. So you want to find that nice, healthy balance. Okay, I'm going to check the chat real quick too, just because I know I'm going over a lot and I'm literally information dumping. So let's check the chat, make sure I didn't go over two things. Hey, Ryan B. Hi, you're new. Welcome in. Welcome in. Great to be here. We're talking about 3D printing. And so lots of information, which should be fun. I created hotkey for the insert polycube macro. Perfect, Jamie. Yep. What's up? What's up? Says B. Hello, hello. Okay, great. Perfect. Don't be afraid to ask questions either. That's what I'm here for. Again, for the next few weeks, we're going to be covering a lot of this stuff. But let's finish this method, and then I'll show you the live Boolean approach. So now that we have this, okay, let's put that back down just a little bit. Now that we have this here, right where we want, this is, of course, the top piece. What I like to do and what I encourage to do it, because now pretty much everybody should have the folder system, even if you're only using 2022 right now, or you've upgraded to 2024, right? You should have the folder system at this point. So I like to use the folder system to keep my keys nice and clean. And this also helps repurposing keys that you create. So I'm going to call this the top cube. Real clever naming, of course. And then I'm going to throw in my key here, and I'm going to select it. Now I'm going to call this my OG key. All right. And sometimes what I will do is I'll Control-Shift-D copy my original key. I'll set that to the bottom and I'll hide it. And the reason why is sometimes when I'm prepping for 3D printing, I'll get really funky and I'll be like, you know what, this key's a square, so this one I'm going to just squeeze it like this. Or this one I'm going to elongate that one. Or this one I'm going to go ahead and actually give it a special cut. So I'm going to tell it that I'm going to cut it like this, right? And then now I have this part. And the reason why you might want to do that is if you have two arms that look very similar to each other and you want to make sure you know which one's the left side and the right side, and you want to make it so easy that you don't even have to name it left or right, you just arm. You'll know because the key is slightly different. So modifying keys is something that a lot of us will do too. So you might want to get into that. And then you might realize down the line that, oh, I modified all my keys. And now none of them is the original one I made. And I really just want a simple key. So I like to save this one down at the bottom. You also can make a ton of different keys and then make them as your own IMM brushes. Save those for later. And then you never have to create a key again, which is perfect. So you'll be able to do that. Awesome. Awesome. So now let's go ahead, and for this one, we're going to name this one the bottom cube. So that way we know which one is which, and we'll name this one the top cube. Perfect. Naming conventions are really important. I try to keep that stuff there. So now here, let's go ahead and just hit save. I'm a big component of like save, 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 save. So I'm going to just click this guy. Oh, okay, cool. So let's just go boom. Sounds great. Okay, so now that we have our keys, the proper key in the folder, these two, we just want to merge them together. So if I were to come through here on the folder, grab the cogwheel and hit merge, now I'm going to have this joined together. But of course, they're just combined. They're not really stitched, and I can tell because I can isolate them, but I do want to stitch these together. Now, a really good feature, and one of the reasons why I argue that it is never going away, and I love it so much, has been one of my favorite features since I got into sculpting, which is DynaMesh. So DynaMesh is, in short, a algorithm that not only rebuilds your topology as you're working on it, but it's designed to delete the internal bits and close all holes. DynaMesh really helps with watertight mesh. And because of that, well, I love to use DynaMesh in order to actually make it so that I don't have to worry if there's a hole. There's a couple ways you can weld things together, and DynaMesh is my favorite way. And again, one of the reasons too is that I will come through here, and let's just make this all visible, is that I can come up to the top and I can save a history state. So I can say Control Tap on this marker, and now this will save as a history state. And the reason why I'm going to want that is I want the look and feel of these nice edges. But again, when I merge together and use DynaMesh, I might get a little bit of a mesh deformation. So I want to be able to call back and get the overall look of this model. So I'm going to go ahead and do that. And then now with the wireframe turned on, I'm going to hover over the resolution slider. Now, before a few years back, I think like 3-4 years ago, maybe 5 now, it's been a while, you used to just have to kind of guess your resolution. How big is something? Yeah, how dense is this versus this? But now we have an actual picker. So it's built into the slider itself, or you can just come to the picker. But if you click and hold on the slider and then you drag over your mesh, it'll actually tell you what resolution that is. And that is resolution 16 based on the size of this right now. So I'm actually going to go a little bit more heavy, more forceful, and I'm going to kick this up to 224. The reason the picker is good is, again, it's just going to tell me what that is, but there's less resolution here and there's more here. So when I weld these together, ZBrush is going to take that resolution and divide it amongst all of it, not just a specific piece. So I actually might lose a little bit of detail. So here it's so low, I'm just going to kick this up a little bit. I don't really mind. I'm going to turn blur off, and then I'm going to go ahead and hit DynaMesh. We're going to give this a second. And while we do that, let me go ahead and check the chat. Layer 1, layer 2, boom, boom, boom. Okay, so it's thinking. So actually that resolution based on their size, that actually might be very, very dense. I probably went a little too dense, to be honest with you. Perfect. Yeah, that's like 7 million. Okay, so that's crazy. Let's back that up and let's hit 56. Let's try that. You can always tell when it's super dense if it's taking ZBrush a while. So now I have this, and it is great. It's got welded together. Perfect. So this is one way to do it. The other way that you can do it is you can do, and I already saw it in the chat as well, and you guys are reading my mind, is that Remesh By Union is a way to go about doing this. Now, the reason why I prefer DynaMesh over Remesh By Union is because of it's already checking for, again, those holes, welding them for me. The one thing I want to call out with Remesh By Union is that here, where we have really big types of quads versus really small quads, when you have the mesh that is not perfectly even to each other, what you're going to risk is having holes show up when you didn't mean them to show up. So you're really going to want to have the quads as even as possible. If I were to do it now the way it is currently, if I come over here, go Remesh By Union, and it's going to do its best to stitch. But you see here how it's, I'm going to lose Leo for a second. So you can see here how it's all trying to stitch all of these different quads into this one vertice here. And each is taking all these different sections. So you might run into a few errors here. The way to really utilize Remesh By Union as much as possible is before we merge it, because it is a fantastic way of going about it. Before we merge it, what we want to do is actually focus on this one, and maybe let's divide this up a little bit more. So let's divide this so that it's a little bit more dense than the rest of them. So then when I merge these folders together, now you can see that's a lot better. Let's actually pick maybe a better, there you go. So you can see now that stitching or the edge loops are a lot closer to each other. So then if I were to come through here and do Remesh By Union, okay, perfect. Now, here, hold on one second. Let's go ahead and just accept that, come back in, Remesh By Union. I'm getting an error here, which is nice. I succeeded but several warnings, blah, 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 blah. Okay, I'm not sure why it's erroring. There it goes. Okay. Now you can see here that it is actually doing a much better job and more vertices can hold that shape, but still it's not quite as even. So you can run into random holes, but that's okay. There's a fix for that. And that is if you do this method, even with the DynaMesh method, I still do this. You come down to geometry, you go to mesh integrity and you check mesh integrity and you check to see if that your mesh integrity passes. A lot of times it will fail if it has holes, if it has floating topology that you may not be able to see with a human eye because it has one poly that is so small that you can't see it and it's floating in space somewhere. There are ways to check for that, but you can see here this looks to be passing. And if I needed to fix anything, I can just quickly hit fix mesh and that does it. Another way you could check to make sure something is watertight is going up to transform and hitting analyze selected subtools. And then it's going to ask you, well, what's the scale of this model? Of course, our scale is in millimeters. We'll click that. It'll come through here. And this is a warning that we'll be getting that says the subtool is not watertight. Now, the not watertight can mean a few things. It can mean that it finds a hole. And even though we asked ZBrush to fix that, it didn't quite catch that. So there's another method for that. So we can check for that. Or there could be a floating piece of topology that we just didn't see and we can't see it. And because it's detecting that there are floating particles or floating bits around it, it will error and say, no, it's just not watertight. And so it's kind of leaving us with a few options. The best things to remember is check to see if you have holes, check to see if everything's welded correctly, and check to see if you have floating particles. And if you go down that checklist, 9 times out of 10, you'll be able to do that. Now, if you are struggling to get it to be watertight in ZBrush, that's okay. Do not worry about that because most slicers today have a fix your model feature built inside of it, which it will pretty much go through, recognize whether or not the model itself is actually able to be printed, and then you could just say run fix and it will do that. Just because for that particular slicer and that particular machine, it might detect something that even ZBrush didn't. And even if it says watertight in ZBrush, sometimes those slicers still detect errors for it, and then they'll go through and recommend you do a fix. And since most slicers now come with that, whatever slicer you're using, it's not going to matter. This is becoming a little bit more of like Way of the Dinosaur, where it's not such a big deal anymore to get it 100% in ZBrush. You can always check it if you're like 99% of the way there and you're like, it's still just not watertight. Just run into your slicer real quick and just check to see if it's there. So we're going to hit cancel on that. Now, again, like I said, I like to do the DynaMesh approach. So I'm just going to go real quick and I'm just going to hit the DynaMesh just because it's my personal favorite. So we're going to lean in on that and we'll just hit it. And of course, it's going to be quite dense. Let's go ahead and check the C here real quick. Boom, boom, boom. Perfect. Fixed mesh integrity might have just fixed, might have just solved months of problems. Absolutely. Yeah, absolutely. Okay, great. So of course, oh yeah, so let's actually roll this down. I'm actually gonna go pretty conservative here. Let's go 64 resolution. Let's just run this in. Again, usually what's cool about DynaMesh is that the denser something is, you start a little bit high and then you work your way down. You're gonna preserve a lot. So now that we have this part, let's go ahead and hit save. And again, too, we can check to see. At the end of the day, we're going to be making a cut here in a little bit, and so we want to be able to just basically, just check to make sure everything's are good. But we'll run our final checks beforehand. And I even too sometimes out of habit will just go up to modify topology, and what I'll do is close holes, weld points, and a lot of times I will just do that out of habit, and then just rerun my DynaMesh, and that usually solves so many issues. But if we come up here to analyze, we say here, you can see here now with the DynaMesh one, it says that it is watertight. And I also did the closed holes and stuff like that. So if it tells you that this is watertight, then you are good to go. Boom, boom, boom. What is the hardware you mounted your tablet to the wall with? Says Jay. So this is actually a articulated arm. I just got it off of Amazon. It was like their universal one. It's actually mounted to my desk. So then it allows me to just reposition this. I am a huge fan of this if you use a display tablet because, quite frankly, looking down a lot is very hard. But also, too, you want to position it in a way that your shoulder is comfortable. I have friends who have ended up having shoulder problems because they're using the tablet in an uncomfortable position. So this allows me to adjust it as I see fit, which is nice. And I don't think it was very expensive. I think when I bought it, it was probably like $100 US. But yeah, I just picked it up off of Amazon. It's pretty cool. So Timothy, I'll answer this question for you just so like everybody knows. So right now we have a link and stuff like that that has been sending people information and updates for ZBrush for iPad. As soon as we have more information, we will be posting that. But just know that ZBrush for iPad is coming, and we have it. Our engineers are working on it day and night. They're going through it. They're really like really. It's don't worry, we're going to have more updates coming, but I'm really excited to showcase it when we finally get the chance. So do not worry. Okay, great. So now, and again, we're just talking about this one key, and I know this is taking some time, but this is super important. Once we get this down, once you're really comfortable with this, everything becomes a possibility. Okay, so now we have the DynaMesh method. Now what we're going to do is I'm going to insert this into a new folder, and we're going to call this cube cut. Okay, and the cube cut is going to allow us at this point to know A, the folder system keeps us organized. What are we doing? And then B, it allows us to duplicate some parts, move some parts out. So for here, what I'm going to do is I'm going to rename my subtool one more time, and I'm going to call this cube cutter, because I'm going to be cutting the lower one, the lower cube with this one. But I need to duplicate this and preserve this because we're going to be using live Boolean next. So here, when you're done with setting the key, pardon me, when you're done with a piece that you're like, it's 100% finished, it has all the keys, it has all the holes in it, I like to go to rename and I type this final top cube. This is where the naming is going to help you out the most. This way I know this is what I'm going to be sending to the printer eventually. I need to still cut the bottom and make sure it all fits, but this right here is not going to have anything else done to it. I'm not going to add any more holes. I'm not going to add any more keys to it. This is finished to me. So I'm going to put that aside, and I usually turn that off, and I come up to the bottom one, and now I'm going to throw the bottom one in, and let's put that towards the top. And now here, again, we're going to be using live Boolean, and I want a little bit more resolution. More resolution is going to save you more problems in the long run than it is, it's going to prevent more problems in the long run than it will cause them. So it never hurts to divide a few and get some denser mesh. When in doubt, just make it dense enough to be used, so like 250,000, that's perfect. That's going to be really, really good. Now here, let's turn solo back off. And now we notice that we have our top key, which is what we're going to use for the cutter. There it is. And then we have the bottom one. So now what we need to do is turn on live Boolean. And with live Boolean turned on, we now need to say which piece is cutting what. So we're going to come on over here. Underneath, we got the bottom cube, and then we have the cube cutter. I'm going to turn this from a basic union to a subtraction. Boom. And there we go. And now it is cutting. Now you might say, great, it's cut, it's done, congratulations. But the answer is no, and it's not. And the reason why is because this is literally leaving us no room for any type of glue. This is a true one-to-one cut. It won't fit because there's not enough space when your print actually shrinks a little bit for this to insert. So what we need to do is we need to pretty much factor in how much it might shrink. And this is where the test cube comes in. And my biggest advice for you is to start a notepad. So go into Notepad, Notes, whatever you feel. Come in here, and let's go ahead and grab this. And what we're going to do is we're going to say, for example, Apex Maker X1 is my printer, and 25.4 millimeter test cube. Okay. And then from here, test cut 1. Test cut 1. And I'm going to write this information down because I've set my model scene, right, based off of my original cube, which is up here at the top. So because of that, then what we basically did is we set up the scene so that we are able to come back and make adjustments when we need it. So here on this cutter, the easiest way, and the way I'm going to show today on how to do it for ease of use and to get you making your key cuts as fast as possible, is with this top piece selected, the one that's actually being the cutter, what I'm going to do is go down to deformation, and we're going to come on down here to inflate. And I'm going to inflate a number. So I'm just going to type in a number. So I'm going to say 2. Yep, that's a little small. I didn't see any change to that. So let's just inflate this and let's go 5. So we're going to do 5 for a second. Now you might not have seen a change. So I'm going to back up and then push forward. And you can see that the cut is actually pushing in a little bit more. And now this is where we can turn on our final cube. And we can, if we zoom in enough, we can actually see that there is, of course, some sort of cut. Now, this is not big enough yet. I can barely see that cut. So I know that's not big enough. So I did 5 on that inflation. So now what I'm going to do is I'm going to hide that one more time, make sure I have the selected cube cutter, which I do. And let's do another 5. So I'm just going to touch that and maybe I'll do another 5 on that. Make that a little bit better. And really what I'm trying to do is inflate this enough to see a difference. So I'm going to turn this back on and I can start to see that there is a space here. Now, this is where you're going to want to like zoom in a lot. So sometimes I'll default to my mouse actually. And I'll just come through here and I'll like zoom all the way in until I can see that cut. Now, again, we're going to get a little bit of imperfections here, but that's okay. These are super small, very small imperfections, so it's not a big deal. I didn't mean to switch that. So let's go and grab just the move brush here. And now that we're zoomed into this cut, I'm going to hold the gizmo. Okay. I'm going to hold the gizmo and then I'm going to turn on Y for my transpose. So I have my transpose tool. I'll alt select this guy. And now what I'm going to do is I'm going to measure from this spot to this spot. Now you want to pick the best spot as possible. We could actually measure it from the highest spot that we see. And of course, this is super small. So as I'm clicking from here to here even, we're noticing that this is only 0.0096 millimeters. This is tiny. This is not big enough to actually help us out. So we need to make this much bigger. But that's an accurate reading. So we know that it's that small because it's an accurate reading. So let's pick that cutter again. And here we should be making our markers. So we did in total of a 10 inflation. So now if I come through here, and let's actually do ourselves one more favor. We're going to hide this guy one more time. We're going to go ahead and let's just scale this up a little bit. So let's just say we inflate a little bit more. Let's go crazy. And let's go 40. Okay, 38. Let's do that. All right. So let's do that cut there. And now let's take a look at it. Now, if you want to get an accurate reading for this, we did the cut. That's okay. So we're going to come in here now. And we can actually come in to the cube cut itself. And we can say, let's go ahead and Boolean this folder. We made the inflation. We're going to go ahead and say Boolean folder. Let's give it some time to make this cut. This is where the most back and forth you're going to do, especially when you're working with a new machine. So here, I'm going to go ahead and say we did 10 plus 38 gives me 48 total inflation on that cut, just so we know what we did. This is important to kind of keep that information. Okay. And so now here we have our top cube and we have our bottom cube. So you can see our bottom cube cut. There it is. And so now we can turn on both the top and the bottom, and we can now see the actual cut line. And now we can actually make a more accurate reading with this cut. So by going up to the folder and saying Boolean the folder, now we can actually see the space that we want. For me, the things that's worked the most across most printers is about, between 0.15 to 0.25 millimeter spacing. Depends on how much the material shrinks and also too how much glue you want to shove in there. I have some friends who are like, I make a giant cut and I just fill it with glue and epoxy and all sorts of stuff. So it really is up to you on that. But here now what we can do is we can come through. Let's turn our gizmo back on. Let's do a quick measurement. And so this is 0.05. So this is still quite tight. It's a really small amount of cut. So of course, at this point, this, in my opinion, wouldn't be big enough. So I'd want to make an adjustment. So let's do that real quickly. And again, this is the way I typically will make a lot of keys. There's another method I'll be showing before the day is out, as we got like another 30 minutes. So I'm going to go ahead and just delete this top, or the bottom piece. I'm going to turn this one back on real fast. And then now what we're doing is we're noting this information down. So 48 inflation is equal to 0.05 millimeters, right? So now we can start saying, well, if we want 0.15, then what we should actually be doing is doing another 100 inflation. And that should give us close to what we want because we already have 50, right? So this is why you note this information down. Again, I told you it's going to be some math. So from here, we're going to come through on this piece here. And luckily for us, inflation only goes to 100. So I'm going to go ahead and inflate that a little bit more. And then we're going to go and do the key cut one more time. So let's go to Boolean and let's Boolean the folder. Again, this is why I love keeping it into folders. So now this gives us the bottom piece. And now, now we can see that gap in there. That's really, really nice. And so for here, we'll just go in and we'll grab this piece and we'll come in and we'll say, and this actually went a little bit more than we thought. This went about 0.185. But for what we're trying to do today, this would be a great test to see how loose it is, to see how tight it still might be. And the reason why I'm actually having you guys do the inflation process today is because it's inflating on all the X, Y, and Z axis, which means that not only is this gap getting that amount of space, but we can check the inside where the key is actually being placed. And the way we can do that is if we come up here, we turn on transpose, and then we flip the normal. So we're going to turn on transpose instead of solo. Then we're going to come down here to the bottom. We're going to go to display properties, and we're going to hit flip. And now what we can do is we can actually zoom in. I'm just going to use my mouse for this just to get quicker. So now we can zoom in and we can see where the key itself is currently at and where the bottom of this is. So we can check this measurement as well. So we could say from here straight down to where this is, right about there. Again, and this gives me a total of 0.245. So that's actually quite big. But again, for a test key, this is how I would go through and find this sizing. So now I would come back over here, make sure I flip my normals back and turn off. And now I have my cube. And again, at the end of the day, what we're going to do is you're going to take these two pieces and you're going to send these pieces independently, of course, to the printer. You're going to print them both together and see how they fit. And this is the starting of making your key cuts. Once you get something that you like and you spend more time experimenting and figuring out the proper keys, then what's going to happen is you're going to have a lot of go-tos. You're going to know exactly how your Anycubic does it, how your Apex Maker does it, how your Elgato, and et cetera, et cetera. You'll be able to really do a lot of that. So once that's all said and done, now what we want to do is we want to prep it for the print process. So what I like to do, and I already kind of called it out earlier, so we're going to do it again, and then I'll check the chat, which is you go to geometry, you come up here, and just rule of thumb, if you just get into this habit, you're probably gonna save yourself stuff. Just go to close holes, weld points, check integrity. Oh, boom, mesh integrity. Two edges, we're sharing two or more of the same polygons. Okay, great. Go ahead and fix that right there. No big deal. And of course, too, when in doubt, you can DynaMesh it, but let's check what that did first. So if we go to Analyze Subtool, come in here, it says it's not watertight. That's fine. We can get our resolution here. Let's kick this up, and we could turn on DynaMesh, and we could check this again. So we could say, okay, our DynaMesh here, let's just check our mesh integrity. Let's fix that. Now, another thing you can do too, actually, and this is something I called out earlier, is I might have floating particles I just didn't realize. In the key cut, you might have created little particles that are floating about. And if you did that, the easiest way to check that, let's just hit solo. is we go to our groups. So I'm going to turn off the lines for a second. Go to Polygroups and hit Auto Groups. Now, if I press and hold the Shift and Control and I use the Select Rec and I select my mesh and then I invert, look at that. If I invert and my model disappears, that means that it didn't disappear. That means that there are floating particles here happening. And this can happen in between your key cuts. So if that's the case, you isolate them out by selecting it, reinvert that, and then come through here. And you're going to go to Geometry, Modify Topology, and Delete Hidden. And now those particles, that's probably what was causing my not watertight. And that's exactly what happened. And now it is watertight. So all of this is all in just kind of make sure. And a lot of times, if you're struggling to get something watertight and you're like, well, it looks welded and I did the weld, close holes, weld points, fixed mesh integrity, blah, 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 and it's still airing out, it's probably that. And if it's not that, and it's still not showing watertight, again, this is why I use DynaMesh. DynaMesh really tends to be the thing that bails me out of the most problems. So that's why it's my personal favorite. But when in doubt, again, you're going to be throwing this into your slicer. And the slicer, I've had models that say it's perfectly watertight, throw it in, and then the slicer says, wrong, it's all red. Can you fix it real quick? And it's probably like one little thing that even ZBrush missed. So that's why it's good to have check and balances and just have a nice solid workflow. So there you go. And now we know, so if we come back up to this guy, we come up here to transform and we check this one, and this one is watertight. Boom, we have watertight mesh. Both their meshes are watertight, and that means they can be printed. So now what we can do is let's go ahead and hit save. Save's our best friend. I'm going to take a sip of water and let's check the chat for that. Go quick here. See if I got any messages. Awesome, awesome. Okay, great. That's so clever. Perfect. Great. Yeah. This is actually a really good call out, Poly Workshop. Just a comment, close holes and weld points is working well, but fixed mesh can sometimes make things a little bit worse depending on the mesh topology. Exactly. Whatever the mesh topology is going to see that it's trying to take the integrity, how the mesh is functioning. If there's a couple edge loops and stuff, or the polys are not quite where it thinks it needs to be, like ZBrush, it's just making the decision based on what it thinks is the best. So it may not always fix your problem. So this is why I think it's good to just go in and just kind of check all that stuff and then rerun your DynaMesh. And DynaMesh is going to solve a lot of that for you. Okay, so now that we have that, of course, we have a total for this active points here is 2.86 million, and this one down here is 3.733 million because I was using DynaMesh and I said, let's give me more topology. Great. Well, how do I then get these to my printer? And then we'll go over some other key cut methods. Well, this is pretty dense. I want to send this to a slicer. Most slicers, I try to keep things in between 250,000 to 700,000 points. That's where I try to keep things. Anything more than that, some slicers do really well at like 1 million. But after that, you're really going to start taxing things. And that's when errors can show up. If your mesh is really, really dense, you're going to push your slicer. And if the slicer can't handle it or it's chugging, then it could just be a really heavy model. So what we're going to do is we're going to decimate this down. So let's go back into Z plugin. Let's again dock this on the left-hand side. Let's go up to Decimation Master. And now my workflow for Decimation Master is as such. I never start at the top and go straight down to the bottom, meaning I don't start at 3.733 million and go all the way to 20,000. That's just not going to give you the best results. What I like to do is if I happen to want to just have poly paint on it for whatever reason, I can say keep and use poly paint. In this case, there's no color information, and also I'm not printing in any type of color. I'm not sending this to Mamaki. Hashtag shout out to Mamaki. If you haven't heard of them, they're amazing. But at the end of the day, I'm not really worried about this. So I do want to decimate these down pretty low. So because it's 3.37 million for this one and 2 point something million for the top one, what I like to do is start down here at the presets, and under custom slider, I will probably kick this to like 750,000. That's pretty good. It can go all the way up to 100, but here to 1,000 or to 1 million. But here we're just going to do 750. That's going to be good enough. No, sorry, Yeah, that's right. Okay, so math, I'm breaking my brain. So now we're going to go through and I'm just going to go ahead and click the custom. Now this might take a second, and sometimes during a stream I might start sounding robotic when this happens because we are asking ZBrush to process, and because ZBrush is CPU based, the heavier the file, sometimes the heavier it can be. I'm on a pretty good machine, so shout out to Ryzen. I think on this one is a Ryzen 9, which is a pretty good CPU. So this is actually running quite nicely, so it's going to go through the percentage. Once you do the initial pre-process and then it comes out to the actual decimation process, then we're going to be coming on and actually it will forever be processed on this model through this session. So I'll be able to step down pretty quick. But again, we have such high density on this that you want to step down in a way that makes the most sense. So it's going to go ahead and reorder. Give it a second. Let me take a sip of water. Perfect. And there we go. So now this went down. So now if we check up here at the top, the active points is now 750,000, which for this shape, that's still quite large. You know what I mean? Like that's pretty massive for what this is. So now I'll step down to 250, 150. Now this is what I'll usually do. I'll usually solo this out. I'm going to look at the visual integrity of this, and I'll kick this down and see how low I can get away with it. It's just a cube. And there you go. That's actually pretty nice. And I stopped at, was it 35? Yeah, 35,000. So this is pretty nice. You do want to be careful when you're decimating down, again, because you might actually warp something. So I'm going to do this to the top cube at the right here. So I'm going to come up to the top cube, and we're going to do this one more time. Also, let's rename. We'll call this final bottom cube. So let's go bottom cube. Boom. Okay, great. So we're going to do that. And then now that we did the bottom one, let's do the top. And again, we're going to do the same thing. So let's go ahead and go through that. And then I'll show you how to export. And then I'll show you the live Boolean approach. And then that's going to wrap up the stream for today. Figure that's a lot of information. Next week, we're going to practice on an actual character. And I'll show you some tips and tricks on that. And I'll show you which character we'll be attempting. I'll show you the Leonardo one a little bit more in depth. But I have a new model I'm working on. I thought this would be perfect, which is, of course, Krang from Teenage Mutant Ninja Turtles. Got a lot of Teenage Mutant Ninja Turtle fan art. I love the new movie, so I think I've just kind of been on a kick for that. Okay, boom, boom, boom. So that went through. That decimated that down. So let's just do a quick step down. And boom. And that looks pretty nice. Great. So of course we can always come through here, right? And what we can do is we can kind of, just check our spacing real quick. We don't really need to measure so much. This could be more of a visualizing one. I typically always recommend, doing your measurements before you start finalizing things. But here you could see that, okay, yeah, that's inserting quite nicely. So this should be good. So this, in theory, should have enough space. And when it bottoms out, it should fit. Perfect. Okay. So now that we have this, let's come back over here. Let's go ahead and flip our normal back because we don't want to have flip normals when we send things out. So let's go ahead, turn off transpose, and let's go ahead and save. So we have this cube here. Now, how do I export this stuff out? So the easiest way to go through this is knowing the fact that when you go to export, you want to make sure that you tell ZBrush what it is you're exporting. Now, under the Scale Master, you can export out from here. However, I like to use 3D Print Hub. I think, there are two different plugins and they both do slightly different things. Scale Master, of course, is controlling the overall scale of your model itself, but 3D Print Hub is going to detect whatever that scale is. We'll have to tell it to do so. So we're going to update the size ratio, and then we're going to export that out. Here's a little fun fact for this. I get this question all the time, so I'm going to throw this disclaimer in immediately, which is this. When you're prepping for export and you're using 3D Print Hub, what you want to do is select the subtool that you want and that you're going to export off of. And you're going to say, update your size ratio using the 3D Print Hub. When you do this, you pick your millimeters. So you say this one. Now here you want to export out immediately. You can export out everything that you see. You can export out one object. or you can export out, everything, including what you don't see. The trick, though, however, is that if I were to switch over here and then hit export, I just set the scene scale on the bottom. I just set the size ratio on the bottom one, and then I move to the top one. When I do this and then I hit export, for whatever reason, that is where you're going to get size discrepancy, because it's pulling the information I told it to pull from the bottom cube. So when you select the subtool that you're like, I want to export all of these, or just the ones that I see, just pick the one that you want to start with, say update that size ratio, then hit millimeters, and then don't switch any subtools. And then from here, you can go to export options and say only the ones that are visible. And then you could say export out to my STL. And then from here, now I actually have a special folder for it. So I come up here, and then I'm going to type in test cube key cut. Boom, perfect. So I have this, and then I'm going to go ahead and say save. So it's going to export out. And then it's going to ask me, how do I want to do this? Do I want to save a subtool as the name there? Do I want to use the subtool name specifically, meaning that it's kind of creating its own name choices on the first one? Second one is if I named it something clever, like Ian, you're awesome. Or if the last one, choice 3, that was a really pat on the back, wasn't it? Or choice 3, you can ask each one to save its own name. So if you didn't name it, and you're like, oh, I really needed to name these, you could do choice 3, and then you can go from there. But here, I'm just going to go ahead and say, just use the names that I gave it, because I already named it. And now my models were successful, and that's really good. So that is how you would go through the whole process. We're going to be doing later in the week, showing you taking it into the slicer, of course. But for right now, I wanted to showcase that. So let me check the way here. So let's see. Oh, thanks, man. I appreciate that. Teenage Mutant Ninja Turtles all the way. Okay, perfect. So at this point now, how do we do another way of cutting? There's another method we can use for key cutting itself. So what I'm going to do is I'm going to go all the way back here. I'm just going to duplicate this one. I'm going to come up here to the top. And now I'm going to go all the way back in history and before I cut it. And I want to do that because I want to show you guys the live Boolean approach. So with this, I'm actually going to put this in a folder and call this live Boolean. And then we'll end up wrapping up the stream for this one. Does anybody have any questions so far on this, on what I've shown so far? Boop. Okay. Well, we'll continue forward, and if there are any questions, awesome blossom. All right, so I'm going to go ahead now. I'm going to come up here to my view, to my visible count, and I'm going to pick visible count 2. If you guys don't know, up here at the top of your subtools, you have visibility, in which you can actually show and hide certain subtools if you would like. So for this one has everything kind of showcased. Everything's pretty much going, and that's fine. What I want to do is actually work with a secondary set. So I'm going to be choosing V2 for a secondary visibility. So that way I don't have to unhide everything. I can just leave it as such. So now let's go ahead and do our key cut. So because we did a lot of things, I'm actually going to go back to this cube, go back to Scale Master, set scene scale. Look at that, it's 25.4. Real quick fun fact too, if you want, you could duplicate your original cube, throw that at the bottom, and call this Scale Master. And Scale Master check, right? And this way, when you open up your project, so let's say you have a giant statue like this Leonardo statue here, I have him exported out at 350 millimeters, so quite tall. I actually would then, I think in the final project, no, right there, there's my bounding box, which we'll get into next week, which is utilizing basically a cube or something that's going to allow me to always make sure the scene is scales set correctly. So a bounding box is really good. Also, fun fact, if you get into making packages for your toys or your prints, then you can actually, use the bounding box to help get a jump start on how much space do you actually need to, quote, fit in that box. So that's going to be a lot of fun. So we're going to talk more about that next week. But for right now, just know that you can keep this cube and just kind of keep that at the bottom. And that's going to be your go-to check. So you don't have to worry about modifying, you can always come down here, set scene scale, and know that that is the 25.4. So just a little friendly tip. So now that we have this, the other way that I recommend doing it, and this is really fun if you just need to make a quick cut and you're just like, yeah, I just need to do something fast, quick, and in a hurry, and that is using live Boolean. And what's fun about live Boolean is you get a little bit different of a variation. If we go back to our notes here, what we did is we did a total, so here of inflation, for this cut, we did a total of 148 inflation, right? Which that equaled to about 0.1875-ish millimeter. So I would then send this, when we send that print in, we can check that. And if we need to make a variation of that, then we can just modify that. And then here I would do live Boolean. And then here, this will be test cut. And I'm going to put in parentheses thickness. If you guys have used dynamic subdivision before, we're going to be using dynamic subdivision and we're going to be using the thickness measurement. So now let's get into that real quick. So here, again, talking about resolution and density of some things. Again, I want to make sure I have enough resolution in my mesh to make the cut so it's nice and clean. So I'm going to divide this a few more times and actually get a nice dense mesh. And then I'm going to go to Subtool and we're going to insert, and we are going to insert now a plane 3D. Now here's the plane 3D. It's nice and small, so let's scale this up. There we go. Perfect. That's enough to really do this thing. Sorry, that was weird. Yes, that's enough to basically incorporate the entire cube. So now what we're going to do is we're going to solo this for a second, and we're going to go to geometry. And we're going to reconstruct subdivision a couple times. And the reason why I want to do that is because I'm going to use ZModeler to make my key. And with the benefit of this key is that you're cutting both sides at the same time. So you're cutting the depth and you're also cutting the you're basically cutting the male and the female components. Those are the original terms for when you have two joining parts. You have your male side and you have your female side. So here we're doing that exact thing. We're going to be creating both of those in one cut, so we don't have to make those independent cuts. The first way I showed you guys is really good for custom key cutting. So when you need to adhere to a shape that is not a straight line and you don't want to deal with planes and warpage and stuff. So the first way is the more common way you'll see with a lot of figures. This way is I just need to make a cut quick, fast, and in a hurry. Of course, you can get very clever very quickly. So I'm going to go ahead and delete lower on this. And now let's use a ZModeler. And we're going to turn on symmetry so we know we're doing a symmetrical chain. And we're just going to, right here in the middle, pick these two here. Now I want to make sure that what I am picking isn't too thick, right? It's not too much for that. So that's actually, for this cube size, that's actually quite a big key cut, but it'll work for this example. So I'm going to go ahead and hide this. And now I'm just going to go ahead and QMesh this out. So I'm going to hover over the space bar, or hover over the face of the space bar, press and hold it, and then polygroup all, QMesh. I'm going to drag this out. And again, we're going to check the distance, make sure that that's not too much, and that's okay. We can actually come through, mask that off, and back that up a little bit. And now we're going to center this into the middle, and then we're going to taper this just like that. So boom, now we have this taper. Now this setup is a little bit different. We're going to be utilizing the ZModeler for this. And again, I want to have nice edge fall off. I want to make sure that the edges are nice and rounded so that they don't cause any issues when I go to insert them. So I'm going to hover over these edges, and I'm actually going to be adding in some custom edge loops. And I'm just going to be supporting each of the corners as we go through. And then here, I'm going to come up here like this, and I'm going to come into the side like this. And so when I hit D for dynamic, you'll see here that this actually has a nice fall off. So if I unshift that and shift that, that's actually pretty nice. Now this is a little bit sharper than the one I showed you originally, but it doesn't really matter too much how sharp it doesn't matter how big or small the fall off is. What matters is you don't have a sharp edge. But we can get very clever with this very quickly. And again, we could just back all this up and we can find something that works. And if you turn on dynamic subdivision while you end up working on the keys themselves, then that could be helpful. So we could come through here. Again, we just don't want any sharp edges. So we want to make sure that we have enough spacing. Not that one there. Okay, great. Let's turn it to the side. Let's come in like this and something like this. So again, we're avoiding sharp edges, but we want just a nice subtle fall off. And that's a lot better. There you go. That's a little bit bigger, and that is going to work out just fine. So now we have this key here. Now what we need to do, of course, is make our cut. So we're going to come in, and because we have this right about there in this position, I'm going to turn this to, of course, our negative cutting. And when you do that, of course, you get that kind of anti-aliasing that happens. What's up, Rafi? How you doing? Annie, how you doing? Annie asks, can you explain the difference between QMesh extrude on model? Yes, I absolutely can do that. Let me finish my quick thought, and then I'll explain that here in a second. Great question, Annie. Hey, what's up, Chris? How you doing? Glad to see you stream again. Yeah, me too. Yeah, for those of you who don't know, I was actually been sick with a kidney stone the last few weeks, and it's been not good. So, okay, so here real quick, what we're going to do now is we're going to go to We're going to go to Dynamic Subdivision, and we're going to apply a thickness. Now, the cool part about this is that this is going to update for us in relatively real time. So we can actually come through, and this is where I say, just pick a number. Like, find something that visually looks kind of nice to you. So let's say 0.075 looks pretty nice. And I can see that cut right there. Now, what we need to do is we need to make this cut, and then we can measure it. But the fun part is that this is dynamic subdivision, which means that we can change this whenever we want. So we're going to come up here to the live Boolean tab. We're going to close this. We're going to come up here to the cog, and we're going to not click Boolean folder, because if we do that, it's going to Boolean just the plane, and we want the thickness. So we need to Boolean with dynamic subdivision, and this will apply that subdivision to the model on export. So if I come in here, do that, boop, and I grab this guy, now I have that thickness. And before I do anything else, just going to use my mouse for this one. I'm going to zoom in. You can see the cut. Let's go ahead and make the measurement. And you guessed it, we're going to hit W. We're going to make sure that we hit Y for our transpose. We're going to click from this point to this point. And look at that. That gave us 0.15 millimeter spacing from top to top. And that is actually really good. Like, we hit the nail right on the head of that. So we go back up here to this guy right here, go into geometry, and we note this down. 0.075 gave us a 0.15 millimeter cut. So we're going to come in here. We're going to say 0.075 is equal to 0.15 millimeters. And of course, this is all off of the 25.4 millimeter test cube. This is the scale we're working at. So this is going to give us a lot of information. That 1-inch cube is telling me that this information here is actually what it is that we need in order to make these cuts correctly. So all of this is going to play in such a huge factor when you start cutting in all your other models. And as a professional toy maker, when I used to work at Funko, these were stuff that, the tool guys would definitely want to have all of this information. This is what they'd be working on. And a lot of times, if I can help them out in my models, I would. Although luckily at Funko, we had our own actual team that did just that. So a lot of times they'd be like, don't worry about it, it's fine. But we'd still want to set our models. We want to prep them to be as user-friendly as possible so that they can make these cuts as easy as possible. So a lot of times we'd start merging tools and stuff together. So this is all good information. And of course, we should save this information, right? So then I would come up here and I would say and I would call this what my printer is. So I would be doing this, for example, for the Apex Maker X1 that I have in my garage. So I go X1, and then I would call this print settings, or name it however you need so you can remember. So then you have this information for next time. But again, if we needed to make an adjustment, we just come back over here and we would just adjust the thickness, and it would get crazy. Now, the one thing that I do want to call out real quickly, and then I'll get into the ZModeler question, which is you want to make sure too that anytime that you're doing these kind of cuts, that If you do have any type of weird, transitions between one plane to another, then you minimize that as much as possible. But if everything is nice and soft and rounded, it should insert in fairly well. So, okay, so Annie, I'm going to answer your question real quick. I'm going to put it up on screen while I do so, and that is the difference between ZModeler and QMesh and Extrude. So Extrude, so if we hover over and we do Extrude, and let's just say all polygroups. I like to do that because I do a lot of temporary poly selections by hitting Alt and just tapping. So Extrude does exactly what you think it does. Extrude is just going to come in here and you tap one and then you start extruding it, right? And if you didn't know, as you're extruding, you tap Alt, you can actually change your polygroup. So nice little fun fact. But let's say I need to actually weld these 2 points together. So with extrude, as I come up, nothing. Like this is a separate extrusion. This extrusion is one, this is a second extrusion. And as I'm doing this, I'm not going to get this to actually connect to this. Like it's not going to, oops, boop. It's not going to weld to it. This is where QMesh comes in. The biggest difference is with QMesh, as I start going, wait, am I on extrude? What's going on here? QMesh, come through here. There we go. Let's try this one more time. It should weld. Why is it not doing that? 1 second. Let's try this again. Let's come up here. Why is it not welding? 1 second. That's a little weird. Boop. Interesting. That's actually not connecting. That's usually the biggest difference. I'm actually perplexed by that. So I may have to figure out why is that happening. Let me try it on a different mesh. 1 second. Let me just come over here real quick. Might have been something that I did. So let's try this one more time. So let's come over here, QMesh that part out, come over here. There we go. Okay. So probably something I did on my mesh, probably because I have thickness turned on. Okay. So here, again, if we go to the extrude function right here, this is extruding. If I want to extrude this one, it's not going to connect to that. In fact, this is a better example because you see that spacing. But if I come over here to QMesh and I extrude this one, and now I want this one to meet, it's automatically going to detect that edge and try to weld that. And this is a watertight weld. This is actually welding itself to that next one. So this is the prime example. So you can get really nice, interesting shapes like this a lot easier than you could, because then I'd have to bridge this and then I have to make that. So that's the main difference. Overall, the function is fairly the same. That's the major difference and why I choose to use I use QMesh over Extrude. So great question, by the way. So what are these objects for? Are you making keycaps? No, Esther, good to see you here. This is the first episode of talking about key cutting inside of ZBrush for your 3D printing. So definitely a lot of fun. That's awesome to know about QMesh. Thanks for your answer. Save me future heartaches. Absolutely. You're absolutely welcome. So that actually wraps up today's episode. Next week, we're going to be covering, again, more in depth about, how I actually went about breaking up this Leonardo. You could see here, I used pretty much the same type of key throughout every process here. So on this guy, I just added a key. The biggest thing, of course, is finding how should I take things and merge them together? When should I merge this or that? And that's what we're going to cover a lot. For this episode, I just really wanted to make sure that we got through the math part of it, because that's a lot of the process. And if you go through and you set up a test cube for every single machine you do, set up a scene, that's just your test cube, save it as a project, and then come through. And then when you get a new machine or you get a brand, or you are just new to 3D printing, you can get that test cube out, you can put it in, you can run it, and then you can start making changes. And then that's how you'll know when somebody comes over, is like, hey, how big should this be? Like, oh, that's going to be 0.125. How do you know that? Well, because that's what my machine's going to do. It's just great information for you. So awesome. Okay. Of course. Well, Angry Monday, thank you for being here, buddy. I appreciate that so much. Even though you're here at the end, I know you came here, and that's all that matters. So thank you so much. And absolutely, you're so welcome. And again, shout out to Poly Workshop, again, to Ma from Lychee Slicer, Definitely an amazing slicer. I love it myself, but also Tomas just a very awesome individual, and you should get to know him. So definitely give that guy a follow. So awesome. Okay, cool. So that being said, I'm going to go ahead and wrap it up with the final stuff and things to do, which is, of course, again, if you need a free shirt, pop on that free shirt. Links and stuff like that will be posted in the chat here in a second. But of course, to ZBrush print prep. Wow, I think I'm the one who helped come up with that. ZBrush print prep, and I am like tongue twisting myself. So yeah, absolutely. So go ahead and get yourself a free T-shirt, and then of course too, if you are a student and you want to get a hold of these tools for the entire year, it's $20 USD. Price may vary depending on what region you're in, but definitely give that a shot. Like again, if you're a student at an EDU or a teacher at a proper EDU, you will be able to get the software. And if you are good at your software and you want to get certified, definitely go and check out the certification process and stuff like that. And then, of course, if you're new and you want to get started, we have a ton of tutorials from the ZBrush and a Carolina one, all the way to Redshift, Cinema, Universe, you name it, we got it. And then from there, of course, if you missed this one, angry if you showed up late, and then you can actually come back. All of the VODs will happen at the Maxon training team. No matter where they're live, when we are live, they all end up here. And this is where you can see all that fun did stuff. Hey, there's my burger. Yay, Ellie. Oh, cool. Shout out to Ellie. She's super awesome. She does Redshift everything. She's helped me out a lot at Redshift, and she took my burger after I was hanging out with Patrick 4D for a little bit, and he got me making food. And here we are, which is cool. And then, of course, events. How do you know that this event goes live and what time, et cetera, et cetera? Boom, we have the event page. Of course, week one, this is what we talked about, 3D printing, how we're going to start with ZBrush. And then we got next week's, as well as the VFX and Chill, and so forth and so forth. So we have a lot of really fun stuff popping up. So, oh, this is actually my live stream. Come see how it's made. I stream pretty much every week on Wednesdays. The times I don't, I'm either at events or, unfortunately, like last 2 weeks, I was pretty sick. So, and then of course too, again, we're Maxon, so we have all the tools you need for start your 3D journey, from ZBrush to Cinema 4D to Redshift, which is a really fun render engine, which is also inside of ZBrush. And just fun fact too, if you come over here to the buy sections, if you didn't know, now you know. When you, if you go on the subscription of ZBrush, Redshift CPU is included in that as well. But Redshift is super affordable, and it works with Maya, it works with Blender, it works with Cinema 4D, it works with ZBrush. So it works across the board with a lot of DCCs. So Redshift is very powerful. It can be used in multiple. And we also have a deal with Adobe Maxon One and Adobe Substance, and we're going to be doing something very fun with them soon as well. So that is it, everybody. Again, thank you guys so much for coming to this first week. I know it was a lot of math, but I'm proud of all of you for hanging out with me. That means a lot. And also, too, you're going to be printing in no time. And if you do 3D print something based on this video, you got those keys and stuff like that happening, please go ahead and reach out to me. Tag me on my socials. It's IR Sculpts. You could tag me all over the place, and I will love to see your work. So that being said, we'll talk to you guys next week. If I see you Wednesday, then I'll see you then. All right. Bye, everybody.